Welcome back to day 2 of our networking series. Look at your device right now. You are connected to a network to watch this video. But is your home Wi-Fi the exact same thing as the internet? The answer is no. While we often use the terms interchangeably, networks actually come in several distinct types, separated by one specific measurable rule. That rule is geographical area. Depending on the physical footprint they cover, networks are categorized into 3 main types: LAN, MAN, and WAN. Before we can understand how digital information actually travels and connects billions of devices, we have to understand these physical boundaries. This illustrates a local area network, or LAN. It covers a single location like your house. Because the area is small, data doesn't travel far to the router. These short distances give LANs high baseline speeds, and an enclosed perimeter makes it easier to secure. A LAN represents the ideal networking scenario, fast and highly secure, but it is strictly limited by physical proximity. Zooming out reveals a Metropolitan Area Network, or MAN. This bridges the gap between a room and a city. You use this for citywide internet or cable networks. Let's test this. If a cable company broadcasts across Mumbai, which network is it? Guess below. Because the geographical boundary covers a city scale rather than a single building or the whole planet, that setup is a MAN. As we expand the network beyond one controlled building and into a sprawling city grid, maintaining baseline speeds and strict security protocols becomes inherently more complex. This global view reveals the Wide Area Network, or WAN, spanning continents. The ultimate example is the global internet. Because data travels thousands of miles across cables, it's noticeably slower. It's also vastly harder to secure, passing through dozens of public, uncontrolled nodes globally. Immense global connectivity comes at a direct, unavoidable cost. You trade baseline transmission speed and absolute security for geographic reach. Categorizing these networks goes beyond basic terminology. The physical size of the network directly dictates how cybersecurity professionals build their defenses. In this split screen on the left, an attack on a LAN is highly localized. The threat is often physical, requiring close proximity to breach the perimeter. On the right, a WAN attack is massive, decentralized, and comes from multiple distant vectors simultaneously. Securing a small physical footprint requires a completely different defensive strategy than protecting a borderless global infrastructure. This cheat sheet maps out the 3 network types based on our geographical rule. We have LAN for a small home area, MAN for a city scale, and WAN for a global scale. The overarching rule is simple. As the geographical size scales up, baseline speed and security scale down. For your homework, identify the exact network connection you are using right now and write down 3 examples for each network type in the comments. Correctly identifying this network architecture is the mandatory foundation. In our next lesson, we will dive into how these networks are shaped when we cover network topologies.